So in this lecture, let us talk about how a postfix expression is evaluated. The evaluation of postfix expression is very simple compared to the logic that we had for conversion of an infix expression to a postfix expression. So let's take an example and see how easy it is to evaluate a postfix expression, again using a stack. So let's take an infix expression and try to convert it to a postfix expression manually and then see how it can be evaluated. In this particular example, I will be using operands which are digits instead of symbols. That will be easier for me to demonstrate it using a program. So consider this following expression. You have 1 plus 2 star 3 plus 4 exponentiation 5. Let's take exponentiation 2 exponentiation 3 instead of exponentiation 5. So this is nothing but the postfix format of this expression is 1 2 plus 3 4 plus 2 3 exponentiation and then exponentiation and then star. So you get 1 2 plus 3 4 plus 2 3 exponentiation star. So let's try to evaluate this postfix expression. As I said before, you have a operand stack into which we put all the operands. In this case, the digits are our operands, so digits go and sit into the operand stack. No operand is directly used in the evaluation before being put onto the stack, and operators are used to decide when we should pop out the operands and then perform the arithmetic logic corresponding to the operator. So again, in this particular scenario, like we have for the infix to postfix conversion, the expression is scanned from left to right, and the tokens are either the operands, which are digits or symbols representing the values, and then operators are the symbols that are representing the arithmetic operation. So we encounter 1 first, put onto the stack. We encounter 2, which is an operand, next, and then that's also put onto the stack. So remember, when you pull out 2 first and then 1 next. So that's something that you have to remember, because when you're applying the operators on these operands, you have to make sure that you apply them in the right way to honor the commutative property of the operator. In the case of plus, it's not very important because a plus b is equal to b plus a. But in cases of operators like minus, you have to be careful because a minus b is not equal to b minus a. So you need to be careful in the order in which you apply the operator on these operands. So the next operator is next token is the operator plus. So you pull out 1 and 2. So you pulled out 2 first and then you pulled out 1 next. But you need to do a 1 plus 2. So the operand that you pulled second is applied to the operand you pulled first, and you perform this operation. You get a result which is 3, which is again pushed into the stack. So these were popped out, and then you have 3. The next token is 3, which is put onto the stack again. Next token is 4. Next is plus. So you take out 4 and 3, add 3 plus 4, which is 7, which is again put onto the stack. You get 2 next, put onto the stack. You get 3 next, put onto the stack. You get an exponentiation operator next. So you pull out 3 and 2 out of the stack. Now we need to be performing 2 exponentiation 3, which is what we perform here, and then the answer is 8. So these are pulled out. 8 is put onto the stack, and then we get another exponentiation. So you pop out 8 and 7, and you perform 7 exponentiation 8, which is put onto the stack, and then you encounter a star at the end. So you pull out 7 power 8 and 3, and you perform 3 star 7 power 8, which is your ultimate answer. So this logic is pretty simple. So you scan the expression left to right. If you discover that you have a operand, push it onto the stack. If you have an operator, pop out the top 2 operands, perform the operation, make sure that the order of the operands is proper, and then push the result back to the stack, and keep doing this until you're done with parsing the whole input expression. So here is a piece of code that does the postfix evaluation. It's pretty simple. So you take in the postfix expression as input. You have a stack that is initialized to put in the operands, which are nothing but digits in our case, or integers in this particular case. And till you encounter the end of the postfix expression, if you encounter a digit, you put the digit onto the stack. I've modified the push operation to make sure it coexists with the push operation that's done for the operator stack. So I named the push operation for the integer stack as iPush, just for the sake of being able to compile and use it in the same program. There might be better ways of doing this again. This is how I made sure that I have two stacks with two different types supported in the same program. And if it is not a operand, if it is an operator, you pop out the top two operands out of the stack, and then you do the calculation of the operands depending on the operator that you have encountered. And this calculate function takes in the operands and then performs the corresponding arithmetic computation and returns the value. And note that I named the operator that I popped out first as operator 2, and then the operator that I popped out next as operator 1, so as to make sure that the right order is maintained when the operation is performed, to honor the commutative property of operators. And once I get the result, I push the result back onto the stack. And this goes on till I encounter the end of the postfix expression. And at the end of this while loop, I have to have only single value remaining in the stack, which is the result. If this is not the case, then the postfix expression is not well formed. I've not handled any errors in this piece of code, but that's something that you can add and improvise upon. So that completes the lecture on applications of stack, infix to postfix conversion, and postfix evaluation. Thank you.